สวัสดีครับ Hello everyone. Today we learn in chapter 4. For this chapter, we will talk about the memory architecture, and I explain you about the TPM, touch platform module in the computer system. The objective after you learn, I think you will understand the memory architecture, and you can explain the address bus, data bus, control signal in the memory, and in the computer system. And you will know the difference between the random access memory and random access data when accessing the data in the memory, and sequential access data, that is access in example is a cassette tape. And finally, I explain you the security system in computers. Here there are the topics, and now we move to the first topic about memory structures. Okay, before we know the memory structure, in the circuit diagram in computer system, they display the circuit cable line in the bus. What is the bus? The bus, this is a group of the cables. The group of the cable by in this example, I have a lot of pin here. If I also a pin, I have this is a 8 pin. That is represent 8 cables. When I drawing the circuit in the computers, I can draw the 8 right cable connect to the circuit, because this is a difficult or complex for user to understand the cable and checking the cable. But for this cable here, this is the same group. This is a group of the port to send the output to the another device. So the circuit maker, they use the bus to connect to the IC and labels the bus name at the head and tails in the bus. Okay, here this is the bus. And now we move to the next line. In the computer have three signal or three T signal for communication. The first, that is the address bus. The address bus, this is consists of a lot of cables inside. The address bus represent the address in the memories and address in the I/O device. The address bus send the data only from the CPU to I/O device. CPU to I/O device. Sometimes a few sends from the small device microcontroller to another device. This is address bus is one directional communication. One directional. What is the meaning of one directional? If I have a position A and device A and device B, device A send the data to the device B. This is a one directional communication. And for the next, that is the data bus. Data bus, this is the represent the data. Number of the buses relate to the number of bits in computer system. If you use a computer in 8-bit system, you have 8 cables in the data bus. And for our computers, we use a 64-bit system. That is 64 cables. And the data bus is a communication inform the send and receive. That is called the bidirectional communication. Example, I have device A and device B here. A send to B, and B can send the data back to A. This is a bidirectional. And the last, that is the control signal. The control signal, this is a one directional communication. The control signal is a many type. That is example, is read, sending the list message to the memory, to the I/O, or sending the write to the I/O and send the enable to disable to the I/O or memory. That is the related to the control signal. And also the clock signal is in the group of the control signal. Here, this is a feature that I draw in that is a represent about the memory in computers. And here this is have a lot of blocks. Is represented like as the cell or memory vector in the memory in computers. And inside the memory have address control to control the location on the memory cells. And here this is a data control to control read or write data in each cell in each box. And also it have read and write signal from the computer sent to read and write. In the memory have a different types. That is RAM, ROM. Inside RAM have a EEPROM, EEPROM. For RAM is a static RAM and dynamic RAM. And today we have a DDR RAM, DRAM 1, 2, 3, 4. That is in different type inside the dynamic memory. So that's what was it I told you. The different type and in the memory have a difference in the memory cell structure, but they have a address controller and data controllers. That is the same structure but different in the cell here. For the next, this is I show you a microcontroller learning board. Is this microcontroller used for the students in university study about the programming to computer and to microcontroller in microcontroller class. In this is have a keyboard. The key is a key the command function and have a 7-segment display in two groups. The first group, this is an address location, and what is a TE? TE is the data or machine code to put in the address 2000. When the programmer write the program, they write in the machine code. Can you remember machine code? Then you write the code in the C language. Example, you write code hello world, and when after you compile the hello world, the compiler will convert your hello world code to the machine code. The machine code represent in the number in a hexadecimal like this, and here this is like as a machine code. When you program directly by write machine code to keep in the memory. And here this is use a CPU, maybe C80 from Xerox. Example, the architecture from C80 from this device. I capture is to the diagram inside the CPU C80. Here this is a diagram inside the CPU C80. When in the in the picture, this is a CPU C80, and here the next page. And for all of this, this is a diagram inside CPU C80. And in this CPU C80, connect to the memory. Here this is a memory type is this EEPROM PROM, EPROM, and in the memory connect the data bus, address bus, and control bus. And inside the CPU architecture, it have a data bus, address bus, control bus. The data in the CPU have a small memory that we call register. For the new architecture, maybe not only have a register, it have a cache memory. For this is a very old architecture. It have only registers. Inside have a register. This is a register name, and here this is a register PC to point at the address in the memory. When you write the program, the register PC changing in any location in memory for listing the data, and have a mechanism inside here to control add, delete, moving data, copy data, shift left, shift right inside the CAT doing here. Okay, now we move to the next line. And here this is a CAT, and this is a memory EEPROM, and here this is a static memory SLAM, and this is a architecture in the CPU CXT. CPU CXT is a 8-bit system. This is during the CXT launch to the market. I think Intel launched the CPU name. This is x86, x86, x86. Okay, now we look at the activity 4.1. For this activity, I have a diagram on the microcontroller Arduinos. In the Arduinos, have connect to the memory and connect to the device. Could you tell me from the 4 box which one is the CPU, which one is the memory? Okay, the answer, where is the CPU? Here, this is CPU Arduinos. The CPU have the data bus data, and here this CPU, this is have the data, and here this is a memory, and now I at the memory have the address bus and data bus, and why the address bus connect to the IC U2 and U3. U2 and UT like as the small memory to capture the address, to capture the data. This CPU send the data 2 times. The first time it send the address, and the second time it send the data by using the same line in communication. It uses the no, I tell you wrong. For this is this IC is send the address by convert from the serial communication here, serial data that is sent from the Arduinos, and Arduino send the serial address and convert to the parallel here, and send it to the memory, and the memory read and write via the data bus here. So here this is a circuit diagram in the computers. I think you don't know, don't have experience about the electronics, but the main point as I told you about the address bus, data bus, and I show you to know the importance of the address bus and data bus. Okay, now we will do the activity 4.2. Here, this activity, we will write the code in C language. And here, this code is very simple. The code display the hello message on screen, but the hello message, when you declaration the variable in the C language, example here, I declaration variable str. The str is a location, any location in the memory, and put the message over to the memory. Now, for this, from line number 8 to number 13, this is will display you the address that gives the hello message by hash collects in the address and the value in hexadecimal in the address. Now we will test this code together by test it on the online TDB. Please open the online TDB and then we'll write this code and run the code. After run the code, I will tell you and explain each line of the code. Okay, now I write the code complete, and here the code I write and show only three text E H E L L H. The H is, look at this H here. H is and this is a decimal, and this is a decimal 84. And here, when I compile the code, run the code, the hash is this is a hexadecimal, and when I change it to the decimal, because the table is decimal, hash is a 100, 104, 100. This is a small letter H, and I look at this is a capital letter H, so I change it back. And S is a 68. This is small letter. S is a small letter here. This is a 60x. 60x hash in the memory at this address memory address C4303 912. This is a keep 60x in the memory. So when you write this code on your computers, it shows different days, because when you run the code in every time, maybe in computer it's change the location into a new location in memory, not the same location. Here, this is the code. The code you compile in C++ or C language, maybe it is generate some warnings here, because this is depend on the compiler. For here, I think it is a 64 bits and show the warning about convert the unsigned integer to long integer, but it is not important for this. This point is show you about the address and the data that keep it in the address in the memory. Now for this topic, we talk about the memory type in each type of the memory. In the memory have divided into types. That is a LOM and RAM. The LOM, this is a read-only memory. You can read only, you can write the only. But sometimes you write it by program in the first time, only one time programming. And the RAM, you can read and write. The main point for different LOM and RAM. The LOM is maintain the data when without any supply. But the RAM is the data will lost when you cut the supply. So in kind the ROM have a PROM, EEPROM, eSwap PROM, and flash memory. For the EEPROM and flash memory, the flash memory is developed from the eSwap PROM. And for today, our memory that we use is a flash memory, example in flash drive. Before I told you the flash drive, I show you the structure in PROM and EEPROM. Okay, for this topics, I order the slide is not ordering. So we move to the slide about the PROM first. Yeah, this is a structure of PROM. The PROM now, this is I think obsolete. We can find the PROM from the chip makers, but you can find the PROM from very old device. Example, in users is from the game cassette. The game cassette inside maybe use a EEPROM or PROM. Okay, in the structure of PROM, in any memory is have address, data, and control is same structure, but difference in the memory cells. The memory cell in PROM is represented by fuse. Yes, it look like a electric fuse, but the fuse is very small. When you program, you burn the fuse. When you burn the fuse in any location, it represents 0. So here this is a one-time programming. And for another device, here this is called EEPROM. EEPROM is a programmer can elazable by take the UV light to the window here. When you look at the window, you will see the chip. This chip is sensitive for the UV light. When you take the high intensive UV to the chip, this will erase the data. By inside the substance in the chip is sensitive to the UV, and when you take the UV, it is change the cell inside here to unprogram to logic. This is a false logic, not 0 or 1. In the EEPROM have a limitation only 100,000 times read or writing the data. Now EEPROM is obsolete. You can find the EEPROM from any microcontroller board in the industry to control own machine. Example here, this is an EEPROM. Most of the EEPROM, when after you program complete, the chip maker will take the sticker to the face of the chip because to protect the UV light. Okay, now for the flash memory, this is developed from EEPROM by use the electrics to erasable, and for flash memory improve the speed read and write, and also is the chip maker develop until to the solid state memory. Now for the RAM have SRAM and DRAM in the main point. The SRAM no refresh, but the DRAM have a refresh. And also in all computers, look at the main board. Here in our computer, we know the name of the RAM is DDR RAM. What is the type of the DDR RAM? The DDR RAM is DRAM, but the improve the speed improved by have a double clock rate and improve by the reading and writing speed. For the main point, move to the main point. We will talk about the SRAM and DRAM. DSM is a memory structure inside, no mechanism about the refresh. Example, what is the SRAM? Here, this is SRAM, and in the computers, it have a cache memory. The cache memory is the SRAM. SRAM read and write very fast when compared to the DRAM, but this is expensive, maybe over 6 times, because in each cell in the SRAM have over 6 transistors, but DRAM have only 1 transistor. Now move to the DRAM. I told you the DRAM have the mechanism about the refresh. What is the refresh? The refresh is like as recharging the capacitor. We know the capacitor, the structure like as a battery. When you charge the power to battery, the battery keep the power for any time, and the voltage will last until the loss before cutting off the threshold of the before 1 or 0. This is a recharge. That is a refresh, called the refresh. In each cell in memory have a capacitor and have a mechanism to recharge or refresh. Every DRAM refresh rate about 60 to 70 milliseconds. 60 to 70 milliseconds. So every 60 milliseconds, the DRAM refresh. Okay, now we will do this activity 4.4. This activity you develop make the circuit from the Tinkercad to simulate charge and discharge. For this, I don't have a time to build the circuits, but I build this circuit and I review the circuits and record the next another video. But you can build this circuit and tell me what's the problem in the class. But now I told you the using in after you build this circuit, after you create this circuit complete and you press this button, and don't forget select the capacitor at select the big capacitor. Here set the capacitor value is 1000 microfarad. When I press this button, the voltage is passed to the button and charged to the capacitors. And when after you press the button out, after remove you don't press the button, the capacitor supply the power to the LED and to the LED to light the LED. LED will give a brightness and take a brightness a few minutes, and then this LED off. So this is charge and discharge capacitor. When you change to a big capacitor, this is a charging and discharging take a long time. For the DRAM, this is a small, very small capacitor. Yet this is architecture of the EEPROM that I told you. EEPROM have a floating gate. When you set read and write, you change the floating gate or structure inside to keep the data. For today, the memory is a very cheap. Here, from the market here, EEPROM 180 bits 16 megabytes. 16 megabytes. This is a price is only 60 baht. And for the DDR-RAM have a double data rate by read and write. That is a rising and falling clocks. Okay, here this activity to connect the Arduino to the EEPROM. I wait for the EEPROM device. After I get the EEPROM device, I will build this activity and give you to build the circuit in the laboratory. In the memory and in the computer system, we have the communication in the two types. That's three types. That is a simplex, full duplex, and half duplex. The simplex is a sending the data sent from the sender to receiver one direction. And for the full duplex, this is a data sent and back. Like as is the bidirectional communication, but in the the meaning of the full duplex have two channels for communication. Here this is a have only one channel. Here this is have two channel. For the half duplex is do like as bidirectional, send and receive, but not send and receive in the same time. Because this have only one channel and it have a mechanism to switch send and receive. That's this we call multiplexers to switch from the sender and receiver used in the same line. Here in this activity 4.5, please told me which one is a full duplex, which one is simplex or half duplex. Here this is a simplex, and this is a half duplex. But in this is a look like a full duplex, but in the mobile phone, it have a half duplex, but switching in very fast, in very fast or very high frequencies. When switching send and receive very high frequency, the sender and receiver is feel like as a full duplex communication, but inside maybe this is built from the half duplex by take the high frequency switching. And for the memory and in the computer have taking the data, access the data in two types. Here this is sequential access. The sequential access like as you write the data on the cassette tape. That means the head of the data write first until the tape roll to end. That is a tell the data right. That is a sequential access. When you read the data, you should read from first to last. But the random access, example, the CD-ROM, MP3, and access in memory. This is a random access. You can move to any location in memory, move to any track in CD, move to any address in memory. Here this is a random access and sequential access comparison. For the activity 4.6, this activity, if you have a time, you can download the program from this link. After you download this program and run this program, the program will change by make a simulation, change your memory to RAM dice. You can set the size. This is a kilobyte, megabyte, and gigabyte. And when you press the OK, this will generate a new letter dice, and you can read and write by keep the data on the RAM dice. But when you turn off the computer, or the data on the RAM dice is lost. the advantage of the lambda is the read and write very fast because the lambda is a use of memory DRAM. The DRAM is a read and write faster than SSD or faster over the hard drive. So some computer that make read more data to compute and write more data to compute. Read and write in many times, maybe implement the lambda to the system. Example, you do the computer for movie editing. During processing or edited movie may be edited on the lambda. Now this topic, I told you about the TPM chip in computers. The computer in workstation and server and only and on the high performance and high-end notebook have a TPM chip. What is a TPM chip? The TPM chip is abbreviation from the touch platform module. This is a module when you install into the motherboard. It have the hardware-based encrypt processor. This chip is generate key like as a random value, like as a random generators, generate key for use in the encryption the data. Now the TPM chip have version 2. You can use it on the Windows 11. Inside the TPM chip have a random number generator, like as a random circuit I told you from the last topics, last chapters. And it have a mechanism about the RSA key generators, hash generators, and store the root key. And so when you install the operating system and you turn on the function about TPM, the hard drive in your computer will encode it. When your hard drive have moved to put on another computer, the hacker or another one cannot read the data because it's encoded the data in the computers. The RSA key is a key sent from the sender to the data. Here this is the data. I have a plain text and encrypt the data, and then the data clip on the computer here by encrypted. Now after write the data on the hard drive and I read the data back, I used to decrypt the data to do the data before encrypted. Here this is activity 4.7. You can encrypt decrypt the data. I have data here. You copy this data and put it to this website to decrypt. And in your computer, you can improve the security by use the BitLock, and you can use the BitLock in your flash drive to protect your data. When you put the flash drive to your computer, and in your computer have a function here, turn on BitLock. When you turn on BitLock and press the password and then save some data to come to flash drive, your data will encrypt it. When you put it your insert your flash drive to another computer and you need to read the data, you will put some passwords to open the drive before open the drive. Okay, yes, type on this activity. Now for this chapter, we move to the end chapters about the, I think you know about the memory and security in the memory. Thank you. สวัสดีครับ บ๊ายบาย